Well, hi, ladies, gents. Okay, so I'm going to go over the ones we chatted about. We can see our first one here with a pattern of -3, -1, 1, 3, and 5. Okay, so first thing to look at when you're trying to solve these is how they're changing. Okay, so you don't necessarily need to worry about what the numbers actually are. It's just how they change from term to term, how that value changes. And you can see that I've highlighted here, these are increasing by 2 every single time, okay? So that change of 2 tells us that, hey, I need to multiply n by 2. If I do that, 2 times 1 would be 2, but we need -3. So what do I have to do to get from 2 to -3? Well, subtract 5, and then that gets us down. And then, like I said, check it for 3 of them. If you can get 3 in a row to work, you know you have it. We'll take a look at the next one here. Okay, so same idea, looking from term number to term number, the value has gone up by 3 very consistently all the way down. Okay, so that tells us we're multiplying n by 3. So if we try that, 3 times 1 is 3. We need 7, so it needs to be 4 higher. Okay, then 2 times 3 would be 6, plus another 4 gives us 10. So 3n plus 4. So this one was a little bit of a challenge, probably. And you can see it's because it involves division. So, number patterns don't always have to be just multiplying and adding. We can divide as well. So starting off, we see that, we are increasing each time, but it's by a decimal. It's increasing by decimal 1, or sorry, decimal 2 each time. Okay. And one of the big hints is down here where it's, if you have 5 of them, now it's worth 1 whole. So 5 divided by 5 would be worth 1 whole. So one, back to a little bit more of a traditional one, just some slightly bigger numbers, increasing by 9 each time, and then we're subtracting 7 to get the number so low. All right, so this one. When we look from term value to term value, from 1 to 4, it increases by 3. 4 to 9, oh, now it's going up by 5. 9 to 16, now up by 7. 16 to 25, now up by 9. Okay, so this is not a linear growth curve. Linear meaning line. So linear, we've seen when you graphed them, and like that one that you handed in from the other day, that's what it looks like when you graph it. If you were to graph these ones, you would be getting something like this. So it would be going along, and then it starts going up faster and faster and faster. Okay, that's exponential growth. If you've been watching in the media recently showing numbers of infected people, this exponential growth curve is what they saw in some countries and some areas, and what they were trying to avoid here. So that whole idea behind flatten the curve, they didn't want the number of infected people to go exponential. They wanted it, they knew it was going to go up, but they wanted it more something like that, not a huge spike. Okay? So anyways, linear growth curve, exponential growth curve. Why is it called exponential? Well, because it starts increasing really fast. So what mathematical operation gets us to get something to increase faster and faster and faster the further you go? Exponents. Okay? And again, we're not stuck to just add, subtract, multiply, and divide for these. You can use everything, including exponents and square roots as well. We didn't get into any square roots with you, but exponents is fair game. So, and I just kept this as n squared. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Okay? And then for this one, we see an increase of 3, then it jumps to 5, then up to 7, then up to 9. So it's the same growth pattern that we saw up top. So that's letting us know, okay, it's probably got something to do with n squared, but then the numbers are off. They're a little bit low for what they should be. So how do we get them down? Well, we're going to subtract 4 off of it. And then our final one, okay? So from 2 to 9, we see an increase of 7. From 9 to 28, ooh, now we're up 19. 20 to 65, up 37. Up 61. So it's growing much, much faster, okay? It's still an exponential growth curve because it gets large. The further you go, the more and more it's increasing. And because it's popping out bigger numbers than up here, we're going to be using a different exponent. So next one to try cubed, or to the exponent 3. So this one would be 1 times 1 times 1, which is still 1. We need 2, so we're going to add 1. 2 times 2 is 4, times 2 is 8, plus another 1 gives us 9. Okay, so that's how this is working. So this would be 3 times 3 times 3, plus another 1 gives us 28. Alrighty, that's it for these. Hope you enjoyed that challenge. Bye for now.